Hello, I'm Mark Cartwright. I have created a short video about Duke's Power Solar Farm installation in Bath County. This installation is approximately 80 acres big, produces 20 megawatts of solar power, and the great thing about this installation is going to bring over $20 million to Beaufort County, which is huge. Duke Power has contracted Sun Energy One to complete this installation. Sun Energy One is owned by Kenny Habul. He runs a great company. Now let's take a look at the shadow line there on this picture. This picture was taken early October, and the shade line is going to grow to winter solstice. So those panels have got to be spaced properly so there won't be any shading. The solar farm installation first starts with the chair rails. They're bolted down with the threaded rod, and concrete pads is placed under each foot. To resist wind uplift on the PV system, these augers are installed by a special machine. Here's a jig that was created to assemble the individual solar panels. 5 panels are stacked in this jig. If you look on the ground, you'll see 2 rails. Those 2 rails are attached to the solar panels, and the solar panel unit is installed on the rail system. And the finished product looks like this. Now we take the solar panels and we attach them perpendicular to the chair rail system. Each section will receive 35 individual solar panels. There'll be 5 up and 7 across. This is how the panels look when they're fully installed. And this is what it looks like from the rear of the installation. This is where all your wiring will take place. We will combine 2 sections and start dividing up our circuits. So these 2 sections will have 70 total solar panels. We'll divide them into 5 circuits or strings, and we'll wire that to the combiner. This is showing a combiner. Each combiner will receive 3 groups. That's 6 sections. There is a total of 15 circuits or strings coming in this combiner. Notice that the positive is the one being fused. The negative comes into a terminal strip. Okay, let's do a quick review. We're going to put 2 sections together and wire them up together. Each section will contain 5 strings. If you look at the bottom there, the highlighted bottom, you notice I'll have 14 panels that are wired together. That's 1 string. So that's 1 circuit that we take to the combiner. Out of these 2 sections, there'll be a total of 5 strings. We have 6 sections, 3 groups, and 15 circuits or strings. As you can see from this diagram, we put 14 individual solar panels to make up 1 string. So every 2 sections you have 5 strings. All of this is run by home runs to the combiner using number 10 AWG. Each section has 5 strings. We combine 3 sections per combiner for a total of 15 strings. Here's a combiner that's already wired up. First, let's take a look at the workmanship. Look how neat it's done. Each wire is identified, the negative white and the positive red. The positive side is going to be fused, and you'll see those on the left. The negative side is not, it just comes into terminal strip. So each negative and positive circuit is combined into 1 circuit that's going to be run to the inverter pad. This is a picture of a combiner in the pull box. The combiner door is closed. What's going to happen here is we're going to pull some wire from the inverter pad, and we will connect to the combiner to bring the solar power to the inverter. The home run to the inverter box is shown in the pull box. This wire will connect to the combiner and bring the power from the solar panels to the inverter. The DC power is brought from the combiner to the inverter pad. It's connected to the inverter and is converted from DC current to AC current. That AC current is now sent to the transformer, and it'll be stepped up to line voltage. I created this video to generate interest in renewable energies. It's not meant to be an installation guide by any means. If you want to learn more about renewable energy, please contact the North Carolina State Solar Center. They have a great program. Thank you.